guys, welcome back. I'm Macon Campbell and this is MaconSTUFF. So today I'll be doing the largest upgrade so far to my Chinese Blue Elephant CNC machine. I'll be ripping out the old Rich Auto A11 CNC controller and I'll be replacing it with the MASSO G3 Touch. So in essence it will be the same machine but totally new brains. So for the past 2 years the Rich Auto controller has been working perfectly fine. There's nothing wrong with it. It is just fairly old school and has very limited features. Some of the features that I'm looking forward to on the MASSO G3 Touch is obviously the touch screen, the wireless capabilities. I'll be able to send and receive files between my PC over wireless to the controller, which means I don't have to run around with a USB stick the whole time transferring files. Also, I will be able to connect my machine to MASSO's app, which means that I'll be able to monitor my machine while it's running, see if there are any errors and stuff like that. I don't know yet whether I'll be able to attach a camera to it, but if I can, that would be really nice too. Then I'll be able to see my machine running while I'm on the go. So just a disclaimer, I am in no way a professional when it comes to wiring these kind of controllers. I've never done it before. Actually, that's a lie. I have done something similar to my laser machine a couple of years ago when I got that, as that thing also had a fairly old controller and I had to replace that. That was a nightmare, but I'm hoping this is going to be a lot easier. Thankfully, MASSO has a wealth of documentation on all of their products. They also have a YouTube channel detailing a lot of the products and the installation instructions for those products. And then if I need to, then I will also lean on MASSO's support staff. If they are anything like their sales staff, then I'm sure that I'm going to have no problems with that. I've also used ChatGPT to help guide me through this process. It has kindly set up a nice upgrade plan for me, step-by-step instructions telling me where to start, where to finish, and everything in between. I've even asked ChatGPT to create me some wiring diagrams for all of the units that need to be connected to each other, namely the MASSO G3 Touch and the lead shine stepper motor drivers, as well as the Fulling, I think it's DZB 300 series inverter or VFD. Now ChatGPT has given me a wiring diagram for all of this, but I'm not going to follow it blindly, obviously. I'm still going to refer to all of the other resources that I do have, as well as the support staff if I need to. But I think I have enough information as a whole to get started with this project. So the first thing I'm going to want to do is install the touch unit on the machine. Now currently I have a controller arm that I built when I just got this machine so that I could have a nice place to put the current controller. Now this controller arm that I designed and built is made from 12mm NDF. I'm not sure whether that's going to be strong enough, but I think for the purposes of getting everything installed and working, I'm just going to use the arm as it is. What I'm going to have to do now quickly is just create an adapter plate between the existing controller mount and the new G3 Touch. So I've already drawn that up in Illustrator using dimensions that I found for the touch unit online. And while I still have full use of this machine, I'm just going to cut that quickly so that I can get the touch unit installed in place where it needs to go, and then it's going to be a whole lot easier to do all the rest of the wiring with the unit in place. So let's get started. Okay, so it's been 2 days since the last clip that you saw because I got a commission job in that needed to get done before I potentially destroy my machine. I've done about as much preparation as I can. I'm armed here with my walkthrough that I generated from ChatGPT. I also have over here a post from MASSO's forum which documents someone doing a similar upgrade to this on a Chinese router similar to mine, only it's a 12 by 12. Now the reason I printed this is because this guy has the same VFD or inverter as I do, and he also has the same controller, the Rich Auto A11, and there is definitely some information in here that could prove helpful in my situation. Also I have this wiring diagram that ChatGPT generated for me, which I don't trust completely, but at least it'll give me a guideline, and that combined with all other information that I have will hopefully see me successfully do this upgrade. So as I said before we get started with that, I'm going to install the touch unit. So I think it's about time that we crack into all of the boxes that I received from MASSO and let's have a look and see what we got. Okay, let's start with the smallest box first. I'm going to unpack all of this stuff over here because obviously once I get started with this machine is not going to be used for anything until it is either fixed or broken. So this over here is the MPG pendant. See, it also comes with a bracket where you can hang it. That's the pendant. Not going to go into too much detail with that, but obviously you can adjust X, Y or Z. I don't know what 4, 5 and 6 is, so you can probably assign those to like a rotary attachment or any other axes that you may have. And then you've got different increments, X1, 10 and 1000. I'm not exactly sure of the increments, but we can discuss that later. And then obviously the wheel which you can use to move your axes around. So that's that. What's in this box? Here's some documentation regarding the app, which I'm definitely going to be using. These over here are the homing sensors. I wasn't planning on using these because my machine has got homing sensors already, but MASSO recommended that it'd be better if I use their homing sensors. So I still have to figure out how and where to install and wire these. This over here is a relay module. To be perfectly honest, I've got absolutely no idea what this is for, but I'll follow the instructions and install it. Then we have 2 cables here. See, they both look exactly the same. 37 pin D male to female cable, 1 piece. I don't know why we need 2 of those, but there they are. We have some nice MASSO stickers. Last thing in this box, this is the MASSO Touch DB connector module. And then the final piece of the puzzle, which is what we're going to be installing first, is this, which is the touch unit. So let's get this out of the box. Now I must say MASSO's packaging and presentation is really nice, very professional, and the touch and feel seems to be really high quality. So let's have a look inside here. We have another giant MASSO sticker. So here's a QR code to scan for installation instructions. Every single one of these boxes has got a QR code on the packaging which links to installation instructions. Here is a little component in here. I don't know what that is, but it looks important, so I'm just going to put that there for now. And there you have it. This is the touch unit for the MASSO controller. I'm not exactly sure if this on and off is only for the unit or if you can wire the entire machine to this on and off switch, so that when you put this on, it turns on the touch unit as well as the CNC machine. Guess we'll be figuring that out soon enough. So here are the mounting points that I cut into the adapter plate that I made for the controller arm. Hopefully those line up. I'm just going to get myself some 4mm nuts and bolts and we can get that installed. Okay, so in order to get inside this box and gain access to these mounting holes, I first need to undo these bolts over here. Okay, that should open this. Okay, so as you can see, this is the actual MASSO controller. If you decide not to get the DB connector module, then you have to run all of your wires from these ports over here directly to your motor drivers and your VFD and your power supplies and all that. And the length of those are obviously going to be dependent on how far away this touch module is from the rest of your components. So I think what's going to happen in this case is this is going to be removed and replaced with the DB connector module, and then this will get installed inside the wiring box. Okay, let's get this installed. Okay, so here I had to remove all of these connectors from the board and install them in the exact same order on the extension board. I tried using masking tape to stick them together, but that made it a little bit difficult to get them pulled out. So I tried something different with the top row, which worked a lot better. Okay, so while I was looking around this board, I realized that there was a section here labeled Wi-Fi, and there's nothing plugged into that, and I was wondering why that was. And then I remembered that small little blue packet that we found inside the box when we were unboxing this, and it is this, and this seems to me like it can fit exactly there. So this can only be the Wi-Fi module. Now, I don't see anything in the documentation about when I'm supposed to install this, but what I do see is in the documentation and in the videos when they're doing the installation of the extension board, this Wi-Fi module is already installed in all the examples. So I'm going to assume that I can go ahead and install this now. So let me just line up these pins and stick this in place. Looking closely at the picture over here, it looks like the Wi-Fi module is installed the other way around. And if you can see right in the bottom corner over there, it seems to be a little plug or a connector. And it looks like that there's a wire that's supposed to be connected to that. Thankfully, I've looked around in the box, and if you can see over here, stuck to the inside of the front panel is the connector that's supposed to be stuck into there. So I'm going to turn this around, and then I'm going to grab this, and then I'm going to connect this to there. Okay, there we go. Okay, so the next step is installing the extension board, and that is this piece right here. So let's open this up. Now apparently this is keyed, so it can only go in one way. So as far as I can tell, it goes in this way. Feels like something is blocking it. I think perhaps these standoffs are too tall. I did see that it came with an extra set of standoffs, these ones which are a bit shorter. So I think I might need to replace these with the shorter ones. So let's do that first. Okay, that's all of them installed. Let's just tighten them a little bit. Okay, let's try this again. Okay, next we got to install all of these terminals back into this extension board. So the first one being the e-stop that goes into terminal number 2 over here. And then the green goes into terminal 1 over here. The blue into terminal 2. And then this red, white and yellow goes into terminal 3. And that's the next step done. So next we've got to connect these 37 pin D cables. Okay, there's a male to female and a female to male. So I'm just going to drop the cable on the floor here, feed it in through the bottom, and we can connect the first one here. The next one. Okay, we've done just about as much as we can do with the touch interface. Connected the extension board. The next thing we need to do is feed these cables into the machine and actually connect everything. But before we do that, my machine is currently still powered on and still running on the Rich Auto controller. Before I go ahead and start disconnecting all of this stuff, I'm going to go through this controller and write down some of the information or values that I think might be important when setting up the MASSO, such as the pulses per millimeter for the X, Y and Z axis, and acceleration and deceleration values. I have already figured out that the max RPM for my spindle, which is a 3 kilowatt spindle, is 24,000 RPM, which is going to be important for when I go to reconfigure the VFD. So let me go jot down those numbers and then we can get started uninstalling the Rich Auto controller. Okay, so before I go ahead and uninstall the controller, I thought it might be a good idea to first go ahead and replace all of the homing sensors with the ones that MASSO sent me. Because once I get started with the wiring, I don't want to have to go back and install more hardware, pull more wires through and then figure out where they go. So I'm going to replace the homing sensors first, get all the wires where they need to be, and then I'll go ahead and figure out the rest. So all of these homing sensors are basically drilled and tapped straight into the machine, and the problem is now the new homing sensors are completely different. It's a different shape, different size. None of the mounting holes are going to work for these homing sensors. So I think the best thing to do is to home the machine so that all the homing sensors are lined up with the metal plates that trigger them, and then I'll try and figure out the best way to mount these. Perhaps I can 3D print some kind of adapter or bracket that can use the existing mounting holes. Otherwise I'll just have to drill and tap new holes for the new homing sensors. Okay, so now that all the axes are homed, I'm going to go ahead and remove all of this Tupperware, this and this. And then I'm also going to go ahead and loosen all of the homing sensors, and then we can try and figure out the best way to mount these. Now, as far as possible, where I can, I'm going to try and use at least one of the mounting holes for the existing homing sensor, and then perhaps try and bend these metal brackets in such a way so that they can activate the homing switches. Okay, so I've hit a bit of a snag here. So even though the wiring inside the cabinet over there is pretty neat and looks quite good, the rest of the wiring around the machine seems a little bit dodgy. As you can see, over here is the Z-axis homing sensor and here is the Z probe. Now all of these wires seem to be jumbled up here, spliced together with, looks like insulation tape, along with the wire from the homing sensor, which comes around here as well. That one comes in here, and this one is the Z that comes around here. And they all spliced together, and along with the Z probe, they are connected into this fatter cable, which then goes down into the drag chain. Now as for the Y-axis, a similar thing is happening here. I can see over here that the current homing sensor has got a brown, black and a blue wire, but then a couple of centimeters further it's spliced to a yellow, orange and a white wire for some reason. And I'm guessing it is then joined by the other homing sensors and then goes into the drag chain over here. So I've got no idea what color the wires are when they come out that side. So I think the only thing that is left for me to do here is to loosen all of these wires, figure out which ones are the homing sensors and which colors are spliced to which colors, and then try my best to remove all of the wires that are connected to the current homing sensors. And then for the new homing sensors, I think I'll just cable tie all of those together so that they can all go together in one neat bundle all the way into the case. So I'll try and get most of that done by myself and not bore you with too much of that, and I'll check back with you a little further down the line.
Many hours later.
Okay, so let me show you what I've done so far. I'm going to switch the camera around. So as I mentioned before, this is the Z probe, which looks like this, which I use to touch off the tool to get the Z height. As you can see, it's got a blue wire and a white wire, which is all connected into this bundle of wires. As you can see, there's pink and a gray here that's not even being used. Those were just closed off. And then the rest of these wires all come from the homing sensors. This one is from this Z homing sensor, and this one goes all the way down here to the X homing sensor. So what I'm going to do is I'm just going to rip this whole cable out, and I'm not worried about this probe over here because I also somehow found over here a giant bundle of wires that is not connected to anything. So as you can see, it is just chopped off, wrapped up, and it's been stuck inside the gantry of the X-axis. So I had to go and do a whole lot of fishing to figure out where all of these wires went, and I eventually found it, and it ended up right here. I have already connected all of the new homing sensors, and I've changed these metal brackets to work with the homing sensors. As you can see, this one I decided to use the same holes that were inside this casting, and I just 3D printed an adapter for that to sit on there. That works quite well. This one over here, I managed to use one of the existing holes, and then I had to drill and tap another hole, and then I just bent this plate a little bit so that it can work for that sensor. And then the same down here, I wasn't able to use the same holes. You see, this is what it came like from the factory, so obviously they drilled some holes and they didn't work, so they drilled more holes. But that's neither here nor there. I drilled 2 more holes of my own and oriented it like this, and then I was able to use the exact same plate. I just had to cut it a bit shorter because it did extend to about there. So basically that is all of the homing sensors sorted out and installed. So now I'm just going to remove the redundant cables, and then I'm going to use that one extra cable that I found inside the gantry, and I'm going to connect that up to the Z probe, and then I'll just bring that down into the box ready for installation onto the MASSO controller. So once that's done, all that is left is to wire everything up and hope that everything works. So I'll be doing most of that off camera, and I'll check back with you soon. Okay, so let's have a look where we're at right now. So this cable over here is the one that I found hidden in the machine, which I connected to the Z probe. As luck would have it, it ended up being too short to reach to where the controller is going to sit. So I'm going to have to extend these wires. These 3 wires I just pulled through now. These are for the homing sensors for X, Y, and Z. This thin one over here is from the Y axis, and that is the only one that is long enough to reach it to the controller. The X and the Z axis were too short, so I had to splice in a new cable somewhere along the drag chain. Now, as you can see, one of these is also still too short, and one of them is the right length, which makes it a little bit harder now for me. But what I think I'm going to do is I'm just going to chop all of these cables off here. I'm guessing and hoping that the positive and the negative, i.e. the power and the ground wires, can be connected together and then put into a single power and ground port on the controller. So that's what I'm going to do. I'm going to chop all of these off, and then I'm going to stick all of the positive and negative terminals onto two single cables, which I'll pull through to where the controller is going to be. And then I'll use the leftover piece over here, which has got 4 cores in it. I'm only going to need 3 wires, and then I'll pull a signal cable from each of them through to the controller as well. Now, these homing switches do have 2 signal cables. They have a normally open and a normally closed, which I think are the black and the white wires. From what I understand, you can use either one of these. So let me get that done. I'll be right back. Okay, so I've done all the wiring that I explained earlier. This is the wiring for the Z probe extended. I've already added on the bootlace ferrules at the end. This bundle over here belongs to all of the homing sensors. As I mentioned, I daisy chained all of the positive and negative terminals together. So this red one is positive and the black one is ground. And then I have this one, which I've connected to one of the signal cables on each of the homing sensors. Doesn't really matter which one is which. I'll just connect them each to their own input terminal on the MASSO. And once I start it up, I can trigger each one of the homing sensors and see which one belongs to which. So I'm just going to lie these in here for now, just to get them out of the way. And with that done, the time has finally come to remove the Rich Auto controller. I'm going to try my very best to get some decent angles so you can see what's going on here. This is a very uncomfortable spot to shoot footage in, and believe me, it's even more uncomfortable to work in. But let's get it done. Okay, so as you can probably tell, there aren't very many options in terms of where I can mount this extension board from MASSO. Obviously the best place would be right there, but the problem is I need to access this port over here and over here for these giant D cables that need to go in there. So this cable holder over here is in the way. Now, this thing did come with these attachments on the side over here, which are click-in adapters for DIN rails. Now, obviously there aren't any DIN rails in this machine, and even if there were, if I mounted them there, there still might not be enough space for this thing to go in. So what I did is I obviously removed these, and I went ahead and I printed this. Looks pretty nice. I even put MASSO on there, and I designed this to have the same hole spacing as the original controller, so I can use the same holes to mount it. And this can go in here, something like that, and then I just attached it with the screws that it came with originally on the side over there. Now, the other thing that I still need to put in here somewhere is this relay module. As I said before, I'm not exactly sure what this is for. I've done a bit of reading, and apparently this is for other extra peripherals that you can attach to your CNC machine, like automatic tool changes, work lights, and all sorts of stuff like that. I don't know if I'm going to be using this, but I will be sure to install it into the machine. So I went ahead and I printed this adapter. I might mount it up here against the side, or maybe here in the middle somewhere. That still remains to be seen. I'm first just going to get this installed, and then we can take it from there. Okay, so as you can see, the MASSO and the relay module have been installed in their final resting place. So the next thing I need to do before I connect all of this stuff is to reconfigure the VFD. So now I've got a power on the machine and hopefully don't blow anything up, and then I can start with this configuration. I have made sure that all of these wires are not touching anything. None of them should have power. The stepper drivers are going to receive power through this transformer or whatever it is, but all the signal cables coming from the stepper drivers are well separated. There is a 24 volt positive and negative coming from this little power supply up here. I've also made sure to separate them and lift them up so that they're not touching anything. So I can't see anything else that could be a problem. So let me fire up this machine and see if we can get this VFD configured. Okay, I've plugged back in the mains, so let's hit this on switch and see what happens. It looks like there's power everywhere. Just make sure not to touch any of these wires. I'll get another camera set up over here so you can hopefully get a better view of what I'm doing over here. Okay, so before I start doing the settings here, I'm just going to disconnect all of these signal wires. I don't think it's necessary, but I'm going to do it anyway while I'm here. Okay, so let's get started. I'm looking at the guide next to me over here. First setting that needs to be changed is F03, and then you press data. It needs to be set to 1, and it is. Then F010 needs to be set to 1. Put that on 1. Escape. So F201 must be set to 2. F02 must be set to 1. And F03 all the way to F06 should be set to no function apparently. F305 2, and then it says F306 should be 255. So I'm gonna just jog, yeah, 2 and 5. So according to the guide I have here, that is all the settings that I need to adjust. Next is the wiring. So for that I'm going to power off and unplug the mains again, and we can get started on the wiring. Okay, one last quick thing before I forget. You'll notice if I zoom in over here, so as you can see there are 3 switches there which are all switched to the top setting. Now the one on the left there that says CI and VI needs to be switched to VI. Now I did a quick Google search, and apparently the machine needs to be powered off for you to change the setting on any of those switches. So I'm going to turn the machine off here, and then I'm going to plug out the mains. So now I'm going to change this one to VI. Hopefully that should be all the configuration needed for the VFD. So next I'm going to start wiring up the MASSO. So let's do it. Okay, let's have a quick look over here. These are the connections that are coming from the motor drivers. Now, as you can see on the motor drive over here, each of them has a direction positive and negative and a pulse positive and negative. The pulse is the same as step, basically. On the Rich Auto controller, as you can see, there's only a pulse and a direction, which is step and direction, but there isn't a positive and a negative. So in the case of the Rich Auto, the direction and pulse negative were connected to the pulse and the direction on the Rich Auto, and then the 2 positive leads were joined together, and those were connected into the 5 volt socket. So what I'm going to have to do for each of these is I'm going to have to cut this connector off and put on 2 new bootlace ferrules so that I can connect them the way they're supposed to be on MASSO's controllers. See, on MASSO you have a step positive and negative and direction positive and negative. which is the same as on the motor driver, so that should work out perfectly. So I'm just going to split all of those, put on the new connectors, and go ahead and connect them. Over here you can see this is for the Y axis. Obviously the Y axis has got two motors, one on the left and one on the right, here labeled Y1 and 2. So those just all get stuck together. Okay, so I've gone ahead and finished up all the wiring as far as I can tell. As you can see, over here are all my motor drivers. I split those wires like I mentioned, and I labeled them. These over here are the connections to the VFD. This is the ground, and then I had to add a second wire over here because the forward and reverse positive terminals 6 and 4 I think have to be connected to the same DCM terminal on the VFD. As you can see over here, this terminal is the DCM, and those two are connected. Then I've got S1 and S2 connected over here. Ground is going to ACM, and then I have this S0 connected to the voltage input, which is connected to terminal 1 over here. Next I went and connected the 24 volt power supply to here. I did see in the manual it recommended that I have to connect a fuse between the power supply and the controller to protect it, but luckily I saw that underneath this plate there is a pre-installed 1 amp fuse, which I'm guessing is there for that purpose. The actual controller doesn't have it, but this extension module does have it. Next thing I wired is the homing switches. There's the power for the homing and the ground for the homing, and then the 3 signal wires for each of the homing sensors. I put on input 7, 8 and 9. And then the only thing that I haven't connected yet is these 2 wires, which are the 2 wires for the Z Touch probe. Now I'm not exactly sure how to connect that yet, so I'm just going to leave that out for now. So the only other thing that I need to do is connect the pendant. There is a connection over here for the pendant. You can see that. And there is of course a possibility that the pendant has to be connected inside the touch over here, so I'll just figure that out quick. Finally, I think it might be time to try and power this thing up. So first things first is I'm just going to clear away all the stuff on the CNC. Then I'm just going to manually push all of the axes just away from the corner, so that if I do jog something and it jogs in the wrong direction, I don't want it crashing into anything. So I'm just going to move all the axes a little bit more to the middle and then power this thing up, see what happens. Okay, it looks like the connector for the MPG is in fact inside the case over here, right over there. This plastic housing gets removed so that the plug can still go in there, but then the wires can get fed down here. Okay, so this is the moment we've all been waiting for. I'm not going to lie, I am pretty nervous right now. Let's see what happens. Wish me luck. Would you look at that? The MASSO is powered on. See, we're greeted here with a welcome screen saying thank you for purchasing MASSO G3 CNC. Controllers are shipped without the main software loaded. Please log into your MASSO account to download the software. So it looks like there's a bit of setup that needs to happen first before I can even start testing this. So let me do that and get back to you. So I've gone ahead and downloaded all the software needed and put it on this memory stick. Now apparently to run it, put the memory stick in here. And then you have to power up the MASSO, and while it's powering up you tap the screen and that will put you into the install files menu. So let's give that a try. So there's a version 5.10 and a version 5.11. I'm not exactly sure what the difference is, but I'm going to choose the latest one, which is 5.11. So let me hit that. keeping my hand close to the off switch here. If this thing powers on and does something weird, I'm just going to shut it down. Okay, it says software update successful, press escape to continue. Okay, let's see what's going on here. It says backup battery error. Backup battery fail detected. So let's see here. There is the battery installed. There. And it's reading 3.2 volts. So that means it's definitely not the battery. So I'm going to put the battery back in. Let's close this. Okay, it's still telling me backup battery error. Voice over Macon here. So it turns out all I needed to do was cycle the unit off for like 5 seconds and on again, just so that the unit could detect the battery, and that worked fine. When I started it up again, the error had disappeared. So now I'm left with a user login here. It's not giving me a username, it's only giving me a password, which is weird. Okay, so I did some reading, and apparently this password is not the password to my MASSO account, it's the password to this MASSO Touch unit. And the default password for this is HTG, which is Hein Technologies Group, in all caps. So HTG, and I'm just not going to change the password, I'll just leave it like that. And there we go. Okay, so now it's telling me to press the e-stop button. I know that there's an e-stop button over here, and there's an e-stop button on the MPG over here. I'm not exactly sure which one I'm supposed to press, or if I could press any one of them. Let's press this one. Release button. Okay, that works. So apparently, according to this, the machine is ready. So we use the MPG. Oh, that is so amazing. The machine is moving. Okay, I'm moving the x-axis, but what I'm noticing here is that the x-axis is moving in the wrong direction. Hey, this is Voice over Macon again. So I muted the video here because I spent literally the next half an hour just figuring stuff out. Now I realize that watching me figure stuff out is not exactly in the scope of this video. I would love to show you how I figured all the stuff out, all the issues that I ran into, and how I managed to get past them, but then this video would end up being 2 hours at least. So I'm going to skip now to the part where I have most of the stuff figured out and I'm ready to start doing my first test cuts. And if you have any questions regarding the setup and the troubleshooting that I went through, just drop it in the comments below and I'll gladly answer all of your questions, or perhaps even do a follow-up video trying to answer all of your questions. Okay, so it's been a couple of days of experimenting, and I've managed to sort some stuff out, and there's a number of other things that I still need to figure out. For example, I've managed to set up my homing. I've managed to set up my soft limits. As you can see, if I jog all the way to the limits, it slows down and stops all by itself. It does the same on all of the axes, so at least that is working. One thing I forgot to mention is that I also managed to calibrate the machine. I wasn't able to use the values from the Rich Auto controller because it used pulses per millimeter and the MASSO uses distance per revolution. But luckily the MASSO has a wizard built in that made the process fairly easy. But some of the stuff that I haven't been able to sort out is the work offsets. As you can see, I've set up a standard bottom left. As most of my work origins I usually have set to the bottom left of my coil board. But for some reason, every time I try to go to the work origin, I get an error that says soft alarm on Z-axis. All of my axes and soft limits are working perfectly. So I don't understand why I'm getting that error. That is something I'm going to have to still figure out. Another thing I haven't managed to figure out yet is this Z probe. I'm pretty sure I've got everything connected the way it's supposed to be, but for some reason when I ground the probe to any metal part of the machine, it's not activating the input on the controller. So that's something I'm still going to have to figure out. So it turns out I had the wiring mostly right. All I needed to do was bridge the input coming from the probe to a 24 volt power input as well, and then stick a 5K 2 ohm resistor in between. And that solved my problem. Thank you very much, support. Obviously I can get around that as well by manually adjusting my Z height, so that's not too much of a problem. So for now at least I think I am in a position where I can actually start doing some test cuts. So let me just wrap up this machine again, get everything back together, and we can take it from there. Okay, so everything is nicely buttoned up, put back together. So this might also be a good time to stick one of these stickers on here. There we go. Powered by MASSO. For the first test cut, I'm just going to do something simple like a basic square and a circle with a predefined size so that I can measure it afterwards and see if my calibration is accurate, and in turn my parts as well. Okay, so this is the first test cut I'm going to do. It's going to be cut out of a scrap piece of 6mm MDF. Basically just going to cut a square, a rectangle and a circle. If this cuts out without any problems, then next I will cut this, which is a commission job that I need to do for a client. This is going to be cut out of teak, and it's a 17mm teak. Okay, so let's go to MASSO link, and apparently you have to type in the folder name where you want it to go into, otherwise it will go to the root directory. I want it to go to G code, and let's grab this. Put it on there and send file. Yeah, that's sent pretty quickly. Now let's go find the other one. Grab both of those, drop them in here. I wonder if you can send more than one at a time. Send that. Okay, now let's go and see if they ended up on the MASSO. So it seems as if there's a limitation there. You can only send one file at a time, which is pretty strange, but let me do that quick. Okay, let's have a look now. Okay, so both of them are there now. So let's check out this first test cut. Double tap it, it should load it up. Now let me go and mark my origin position and zero all my axes and see if this thing will cut. I need to do is start. Okay, it's running. Okay, it seems to have cut out. Everything looks good. I haven't measured anything yet, but one thing that I did notice that was fairly concerning is that it didn't wait for the spindle to get up to speed before it started cutting. It just dove down while the spindle was still ramping up and started cutting. I don't know if you heard that sound, but that's not very good. If this was teak or anything harder than MDF, that bit would have broken instantly. So I'll obviously have to figure out how to fix that problem before I go to cut the next project. But before I do that, let me measure this and see how close we are to 150, which it's supposed to be. Pretty much on point. 150, it might actually be like less than half a millimeter shorter. Okay, I can still play around with the calibration wizard, but for the project that I'm cutting next, I think that is more than accurate enough. But I'm not going to even attempt to cut into teak until I figure out why it started cutting before the spindle ramped up to speed. Okay guys, I'm going to cut this video short here. I know it's quite a long one already, but I do think that this video will be helpful and perhaps even invaluable to anyone else who's doing a similar upgrade to this. I was lucky enough to find that post on the MASSO forum, but obviously all text-based, that I managed to get through it, but I would have loved to have had a video like this before I dived into an upgrade like this. Now, as of today, all of the issues that I mentioned during the video that I've had with the setup and the integration have all been sorted out. MASSO support team has been incredibly helpful. I haven't had to wait for longer than a day for a reply from the support team. In some cases way less than that, and my replies were all concise and to the point and extremely helpful. And as a result, everything that I need to have working as a starting point for this controller is currently working 100%. Obviously there are going to be some add-ons and things that I'm going to change in the future. As I mentioned, I would love to be able to connect my water cooling for the spindle and my dust extraction to the machine so that when I turn it on, that those things can turn on automatically, or perhaps if there's even a way that I can set it to only run once the spindle starts working. I'm not sure if that's possible, but I'll be looking into that and trying to figure that out in the future. Also other things such as a proper touch-off block. I want to either purchase or make a touch-off block that can set the Z height as well as the X and Y for my material, which I think will be super useful. But for the time being, everything is working just as it did with my last controller, with a couple of obvious added improvements. So with all that said, I'm going to wrap up this video by saying thank you very much for watching. I hope you found it helpful, and if you're doing an upgrade like this, if you have any questions about this process that I didn't cover in this video, you're more than welcome to post those comments below, and I will most definitely help you as best I can. And lastly, I'm not sure if I mentioned it in this video, but one of the reasons that I did this controller upgrade is actually in preparation for another upgrade that's coming shortly, which is going to be the installation of a laser system on the CNC. It is a 45-watt diode laser made by OptLaser, which is made specifically for integration with CNC machines. Unfortunately, the laser was not compatible with the Rich Auto controller that I had on here, hence the need for this upgrade. Now, I didn't have to go for the MASSO. I could have gone with a number of other controllers, but I'm not going to go too much into detail about that now. I will be covering all of that stuff in that video when it comes out. So if there are any of you who are interested in that, stay tuned, subscribe so that you don't miss out on that video. And finally, as always, till next time, keep making stuff.